In this video, we're going to identify the domain of a logarithmic function. It says, what is the domain of g of x equals log base 10 of 16x minus x squared? The first thing I need to recognize is that the inside of a logarithm has to be greater than 0. I can never have a number that's negative inside a logarithm, because if I were to write this logarithm so I'm replacing g of x with y, and I'm going to write this as an exponential, I would notice that, so 10 to the y power is equal to 16x minus x squared. I would notice that 10 to any power never gives me a negative in here, so I'll never get a negative. And then 10 to this y power will never give me 0. So I'll never get 0 in here. So I just need to write 16x minus x squared greater than 0 to start finding this domain. Well, this is a quadratic inequality. So I'm going to write that as negative x squared plus 16x greater than 0. I'm going to factor, well, I'm going to divide a negative out of each term. That's going to flip the sign on the inequality sign. And then to solve this quadratic inequality, I essentially ignore the inequality sign and I write x squared minus 16x equals 0. And I solve for the zeros. So factor x out. And then ZPP, zero product property. So I get x equals 0 or x minus 16 equals 0. So I end up with x equals 0 or x equals 16 for my zeros. I draw a number line. I plug in, or I got 0 and 16. Those are both open dots because if I plug them into the original inequality, that inequality cannot equal 0. So these zeros are not actually solutions for us. And then I want to take this, I'm going to take this version of it, the x parentheses x minus 16. So x minus 16 has to be less than 0 from that inequality. I'm going to start plugging numbers in these different quadrants to see where are the solution, or where are the domain values. So I'm going to plug in negative 1, 1, and 20. Negative 1, when I plug it in here, I'm going to get negative, let's see, if I plug in x equal negative 1, that's going to give you negative 1 minus 16, less than 0. That's a negative, so I end up with a positive number, less than 0. So that is no go on that. This area is not part of the domain. I plug in a 1, x equal 1. That'd be 1 minus 16, less than 0. This is negative. Negative number less than 0. Yes, that works. So this area has solutions. And then x equal 20. I get 20 minus 16, less than 0. You can see that 20 times, this will be 4. That'll be a positive number, so this area does not work. So our domain then for this logarithm would be 0 to 16 with parentheses.